Well, hello, everybody. I think it's a good morning for some, good afternoon for others. My name is Stephen Yates, and I'm Executive Vice President with Buildxact, responsible for the North American market. Buildxact is a construction management software solution, a cloud-based software solution. And our mission, very simply, is to make the residential construction industry simpler, more efficient, and more successful. And indeed, that success includes encouraging, fostering, and facilitating the adoption of green building practices. So with that, and therefore, we're absolutely delighted to have Sam Rashkin join us today. Sam is the founder of Retooling the U.S. housing industry. And Sam is going to spend 15 minutes or so taking us through some of his thoughts and some of his work that is going on right at this very moment to help builders to adopt green building practices. So with that, Sam, I'm excited to hear what you've got to say. I'm looking forward to learning something today. And after Sam speaks for a few minutes, we will hand over to Alex Volney from Buildxact, and Alex will show you all how you can actually implement some of Sam's ideas using Buildxact. At the end of that period, we'll be about 30 minutes in, and that should leave us about 15 minutes that we can all get together and have a chat about what we've learned from Alex and Sam today. So thank you very much, Sam. Over to you. I look forward to hearing your session.
Hey, thank you, Steve. And most of you probably know me from my work as National Director for Energy Star Certified Home. We grew that program. Now it's on its way to 2.5 million labeled homes. And as Chief Architect with DOE, leading the Zero Energy Ready Home program. So for the past 6 months, I've been focused on a broader perspective on housing, moving also to green and zero carbon performance, and embracing the total user experience that I'll cover more later. But today I want to focus on how to design and build smart, profitable, all-electric homes. And if you're going to hear a constant theme, like Steve, I'm obsessive about simple. So a lot of times I'll be emphasizing how it's always a more profitable solution to always move towards greater simplicity. Now, the outline for today, I'm going to cover the zero carbon movement. It's left the station, and I think we all should realize with certainty this is a future for the housing industry. And then moving towards simplicity, I'd like to lay out basic building blocks that keep zero carbon simple. If you do these basic strategies, this is the way you get to zero carbon. And I also want to move to a understanding that zero carbon is a journey. It's a path we're all going to get on, and all the various steps of the path are fair and viable choices for builders. I hate being judgmental, but I want to lay out just the journey that I think all of us will be on and how to get there, and wrap up with this realization that I've come to, that zero carbon is critical, but it's not enough. And I'm going to speak to how you get to a comprehensive user experience in this last section. So zero has left the station. We know this from all the various data points and metrics we look at. First, the first metric that shows the path we're on to zero is just how rigorous energy codes are getting more and more over time. And if you look at this curve, the vertical axis is the energy use index. It's referenced to the 1975 code. The horizontal axis is time. And what you should know, in the last decade and a half, a 40% increase in rigor in the National International Energy Conservation Code. And I'm going to suggest later in more detail how that latest code is in fact a zero energy ready enclosure code for the entire country. On top of the codes getting more rigorous, you should also note that a lot of states beyond the national code are adopting codes that are already targeting zero. A lot of these we know about: California, Oregon's on the path, Washington State, Eastern states, New Jersey, New York, New Mexico. And the big one, again, I want to highlight is 21 IECC National Code. This is a ready off-the-shelf solution for the entire country all states and jurisdictions can go there and have a great platform for moving their market to zero. And on top of that, we can also just look at the HERS scores. This metric shows how fast and far the industry has come. Last full year of HERS ratings was 2020, nearly 300,000, and the average HERS index is a 58. Most zero energy enclosures, you're targeting low 40s. If you get to the most aggressive programs like Passive House, you might be in the mid 30s, but that's like really the extreme limit of just enclosures. But anything the low 40s, even mid 40s, I'd suggest you're at a peak point for cost effectiveness. And already we see a HERS index average for 300,000 homes out of, let's say, 650,000 single family homes, and we have a rating that's below 60, when the average IECC home at this time is about 70. So the market's going there just by looking at HERS scores. And we also can look at state policies, and across the board, we see more and more states making major commitments over the next 20 to 30 years to virtually be carbon-free in their electric production. So that's enough about just why I believe zero is the future. Now, how can we simply be in the path to getting that in terms of simple building blocks that are the strategic and prudent way to get there? And the way I like to go after this first is to show the relationship between greater performance and greater risk. So we can take an example, let's say airplane industry, and the two key metrics, speed on the horizontal axis, elevation on the vertical axis. First, airplanes went fairly slow, 80, 85 miles an hour, low elevation, a few thousand feet. And then we go to greater performance airplanes at much higher speed, and they're faster, better, safer, more comfortable. This was an easy choice to make for the industry, but there was greater risk. At higher levels, you have hardly any oxygen, so you need to have pressurized cabins and oxygen masks in case of problems. You're flying at 400 or 500 miles an hour instead of 85, so you need lighter, stronger materials. The temperature is minus 40, 50 degrees at 30, 40,000 feet, so you need better thermal control. And with all these thousands and tens of thousands of planes in the air, for avoiding collision, you need advanced radar detection systems, and then you manage the risk. So the greater risk, you don't stop the innovation. The innovation has a responsibility to embrace and address and solve the risk. That's all I want to say there. And when we get to housing, it's the same exact thing. The difference here in on the horizontal axis, we'll talk about thermal resistance, and on the vertical axis, we'll talk about airtightness. And if you look at the homes built in the mid-70s, they were pretty energy inefficient. And of course, you want to go to high performance enclosures. They're lower bills, more comfort, more health, durability, safety. Of course, you want to do this. Now, I know I frustrate a lot of folks, even in my own shop at DOE, when I would also suggest there's greater risk for high performance. But I'm transparent. You got to know there's greater risk. In fact, as we increase the performance of the enclosure, we are taking on substantially greater risk with moisture, comfort, and indoor air quality. So it doesn't mean we don't do high performance enclosures. It means we do them and we manage the risk. So why are those risks there with a better enclosure? Well, what happens when we go to a high performance energy efficient enclosure is they're much more airtight and much better insulated. So there's less thermal flow going through assemblies and dramatically less airflow going through assemblies. So the reason the moisture risk is greater is they're now creating a much colder surface inside the cavity. And therefore we have more wetting potential at that lower temperature, while we have so much less drying potential because less heat is getting through to dry the assembly. So in all construction, if it got a little wet, it could dry, no grace period. Now you have to manage that risk. Second risk is comfort. And the reason for that is with a much higher performing enclosure, now you have much dramatically reduced BTUs needed to heat or cool the space. So the air duct systems for heating and cooling have much less airflow, while we have done a very poor job of delivering consistently high quality ducts with low air leakage and good design. We also have shorter cycles because we need so little BTUs to meet our thermal requirements. In an air conditioning mode, the system is cycling at a much shorter time, removing much less moisture, creating much more risk of higher humidity indoors in our homes. And the longer swing seasons could be adding 1.5 to 1 month on the front and back end. That could be 2.5, 3 months a year when we had air conditioning and we don't, but we still would have latent loads. And now we don't get that accidental dehumidification as a byproduct of the air conditioning. So we have greater risk of higher humidity in the homes. So we have to manage those comfort risks. And then on the air quality side, this is the most obvious, that when we have tighter construction, we still must figure out how to dilute contaminants that get in our home. And lastly, I'll add, there are also risks about being future ready. If we build zero carbon buildings, my goodness, these are buildings that should stand the test of time. They're durable, comfortable, ready to last hundreds of years. And if we ignore resilience, water constraints, electrification, embodied carbon, and I'll speak more later about the user experience, then we are kind of like undermining this really long-term durability capability with zero carbon buildings. They must stand the test of time and be future ready. And so this leads me to the basic simple building blocks that are your sure way to do zero carbon efficiently, effectively, with the best results. First and foremost, with no exception, you start with a high performance enclosure. You want to optimize energy, air leakage, moisture control, all those vapor control, all the performance key concepts have to be optimized. When you do that, by the way, now more than half the energy consumption will be all the equipment and appliances and fans and lighting inside, so those have to be efficient as well. Step two, you have to manage those risks, which come along for the ride with the high performance enclosure. So we need comprehensive moisture control, comprehensive comfort, quality comfort installation, and we need comprehensive indoor air quality. And lastly, to be future ready, more and more, I'm hoping the industry realizes that resilience is not extra credit, water efficiency is not extra credit, electric ready is not extra credit, and embodied carbon has to be more and more addressed. And at the very end, I'll talk more about this concept of optimizing user experience and why I believe it is absolutely critical for high performance builders. So let's just look at some of the basics and see if this leads to some really compelling recommendations about how we can move forward and do zero carbon with the best solutions. So when it comes to optimizing the enclosure, building science tells us we need the 4 control layers: air, thermal, bulk moisture, and moisture vapor. And this is mandatory and with no exception again, because this is like a 100-year opportunity cost. If we don't get all these control layers integrated and optimized, we can't go back and change. We're locked in with the enclosure assemblies. We can't change the insulation, the air tightness easily, the moisture control layers easily. We have to get this right. And the other reason is that efficiency with optimized enclosures, we get energy efficient performance when we particularly optimize a thermal control layer. Plus we get the critical moisture control, and we start addressing the comfort risk and the air quality risk. So this is why this is where you begin. Now, airflow is a matter of air barriers, air sealing, and flashing large openings. We don't have enough time today to cover these in detail. I've done 8-hour training programs just on doing air barriers. But the key thing to note is that there are obvious and usual suspects when it comes to all these measures. And for air barriers, for instance, are shown here. These are the key air barriers. And with simple checklists like the thermal bypass checklist that we did with Energy Star, that's now part of the energy codes, we can address this fairly easily. This isn't a big secret how to do this. On air sealing, there are lots of different targets that are given for different programs: Zero Energy Ready Home, Energy Star version 3, version 1, the codes themselves. Passive House has various levels for ACH 50 requirements. Let me just keep it simple. Everyone in all climates should be at least 1.5 air change per hour. Just make that your target. If you're in the colder climate zones like 6, 7, 8, I would recommend 1.0 ACH 50. Let's keep this simple. We can do this. This isn't a mystery anymore. We know how to do air sealing effectively. And so again, usual suspects of penetrations, cracks. There are about a half-mile cracks in an average home, and that those geometry challenges that come up with complicated designs, they have to be managed. cantilevers, knee walls, but we know how to do these. It's a basic checklist approach how to do them. What I want to highlight is that the most egregious interface, though, is the attic to the ceiling below. This is where you have the maximum delta T, delta temperature difference. In the summer, it could be 130 degrees. In most climates, in the really hot Western climates, it could be 150 to 180 degrees. This is the most egregious interface for temperature. Also, it's the most pressure in terms of internal pressures because of the stack effect constantly pushing hot air to rise and create a pressure differential between the inside and the attic. And then you have all these nasty air barriers that can crop up, the knee walls, raise and drop ceilings, wind baffles at the attic eaves, air leakage with penetrations, duct boots, shafts, access panels, and the entire footprint of the floor plan where the drywall meets the top plate on both sides of the wall has to be completely sealed. This is the absolute worst location for HVAC, and you go west of the Mississippi or western region of the country, and for some reason we're still putting HVAC air handlers and duct systems in attics. This is just not going to get the job done for a zero carbon building. We have to address this. And so I want to highlight one of the most egregious parts of a typical attic construction is the missing air barrier. What we do to make sure we have complete air barriers is we take a red pencil, we draw a continuous line for the outside air barrier and the inside air barrier without lifting the pencil, and then we know we're complete. If I do this for conventional framing, this is what I get. And what you should note is there's no air barrier in the top side of the insulation. We're missing a critical air barrier on almost half of the attic insulation, which is the thermal buffer between the most egregious interface we have, the attic and the ceiling conditioned space below. So I'm going to suggest when you look at a unvented attic with like SIP roofs or closed cell foam, you get a complete six-sided assembly on the entire home, the foundation, the walls, windows, and attic. And this is where you want to be. And so this should be, for me, two key points to raise. One is if you're doing new construction, I keep imploring the entire industry to move towards unvented attics, more about the user experience benefits that we can capture later. And secondly, we have this massive infrastructure, housing infrastructure of about 120 million housing units and about, I think, almost 1,900,000 are single family homes. We should know it's obvious what you do. Just set up comprehensive attic upgrade programs. We make our existing home strategies way too complex. Remember, the theme today is simplicity. If we just set up an infrastructure that not just did insulation, but air sealing and air barriers and did a comprehensive attic upgrade, if there are any ducts up there, would do some basic sealing, you would be able to get the biggest impact for the least cost. So that would be my key point and takeaway about what understanding the building blocks for zero carbon. Now on thermal flow control, it's not just insulation quantity. Way beyond that, it's the quality of the installation of that insulation, it's minimizing thermal bridging, it's optimizing window selection, and radiant barriers kicks in a little bit for some situations. But thermal flow control is going to be a much more exponentially growing accountability because infrared cameras are going to reveal thermal control defects. And when you see them as a homeowner, this is high impact because it's emotional to see the biggest asset you own, your house, with a glaring defect like all that red on your home. It's emotional. People understand that this is not a properly built house. And again, I'm going to cite that the 2021 IECC is a great way to get to the right quantity. From a lot of our calculations we did when I was at DOE, it's really approaching maximum cost effectiveness if it isn't already there. And the key things between all these different levels I show for 2015, 2018, and 2021 code requirements for the different components of a home, I want to show you why 2021 is such a great zero carbon code. First, for slab depth, it finally is introducing slab edge insulation, at least prescriptively as a requirement in climate zone 3. All our calculations show that is a huge place for thermal heat gain in the summer and thermal losses in the winter. So very importantly, the 2021 IECC brings slab edge insulation into climate zone 3 for that critical part of thermal loss. Floors are fine, but when we get to ceilings, the prescriptive levels jump to 49 and 60. And you need to understand, if you have an unvented attic, that will drop the 49 to about 40, the 60 to about 50, and raised hill trusses will further drop it to about 49 to about a, kind of again, about a 38, 36, 35, the 60 to about a 45. It gets to be much more reasonable numbers when you factor in the other things you do inherently with high performance. If you have unvented attic and effectively the benefit of a raised hill truss equivalent, your prescriptive numbers drop to levels that are much more achievable. And that's where you want to be. And then on walls, what I think is critical about the 2021 IECC is it forces more thermal bridging in the colder climates. You see that you can't do it just in R20 advanced framing in climate zones 4. And in climate zone 5, you're going to bump up the 13 plus 5 to 13 plus 10. And the colder climates as well, you're going to move to much more effective levels of thermal bridging control with either rigid insulation or using advanced wall systems like SIPs or insulated concrete panels. So this is where I believe you want to be for quantity. If you want to go to the more aggressive programs and mention passive house and those numbers can work for you, great. But I think this is a great point because when we do the math, it takes a very manageable solar electric system or off-site renewables to then offset all your on-site consumption if you do this level of enclosure, plus the energy efficient components. And also I like people to be aware that there's solutions we're not even beginning to embrace at the level I think we should. Like precast concrete foundations are so much better insulated, so much more thermal control, because in this case, this product has a complete R10 rigid insulation covering both the outside wall and the ribs that are used for structural purposes, and has a cavity to bring up the insulation inside to R20 plus in the basement. Plus, it's a stronger foundation, much like an effective bond beam than to do poured concrete. It's almost double the moisture protection, 5,000 PSI versus 3,000 for poured concrete. I can build it faster with less construction time. It's more dimensionally accurate. It sets perfectly true. There's some extra work in the field to make sure it's ready to be set perfectly level. And then it uses 70% less concrete than a poured concrete foundation. So when we start going to zero carbon, we really have to think about these kinds of solutions as well. And then we have to really figure out solutions for the trouble spots. We know band joists are hard. For instance, they have gaps, voids, compression, and misalignment, which is in effect no air barrier when we use fibrous insulation in the band joists. And that means moisture flow, vapor flow can get to that outside cold surface. So we have to have solutions for these challenging points. They show up in infrared images as a glaring defect if they're not done right. So either spray foam or a SIP band joist are great solutions that we have to start making mandatory in zero carbon homes. And this is a picture of an Energy Star home, and you can see it's just excessive thermal bridging. And we can't allow that. You have to go to less. Even a home with reasonable amount of framing, conventional framing, will have very high levels. If you do the calculations for all the different wall assemblies, just conventional 2x4 or 2x6, 16 on center is about 25 to 30% framing factor. So that means a quarter to almost a third of the wall has 1/4 the insulation value of the rest of the wall. Even advanced framing is almost a 20% framing factor. Some of my friends in the industry do staggered stud framing. You're still left with about 12% framing factor. Even double wall framing is about 10% framing factor. I believe everyone needs to be around 5% or less. So again, I strongly encourage people to think about advanced wall systems like structural insulated panels or insulated concrete forms, or they can make rigid insulated sheathing work. That would get you down 2% framing factor. I'm indifferent. Once I'm to 5%, I'm good. But I believe everyone needs to be at 5%. And this is the reason, again, I was so glad to see that 2021 IACC is making slab edge insulation mandatory. It's just, again, an egregious thermal bypass in construction. You can do everything else right, and you'll have a glaring funnel for thermal flow to take moisture out in the winter and in the summer. So in climates that are less rigorous, you can do basic rigid insulation along the foundation. I love this technique. It's done a lot in Sweden, and it's great. Just get rid of the basement altogether and do this, basically this insulated foundation form, and that just is an amazingly effective thermal break and effective amount of thermal insulation between the slab and the home. Don't forget, the ground temperature year-round is about 50 degrees in most climates, 55 in the more mild climates. So I'm always amazed to see how much slab and foundation insulation is used, particularly in passive homes. I don't know how it could be cost effective beyond a couple of inches below the slab, but these are great solutions that we can look for. And then recognize the next funnel for thermal flow in and out of the home are our windows. And this is particularly going to be in colder climates. In warm climates where your cooling is the major load, the cooling design temperature will be about 95 degrees. The indoor temperature may be 70. So you're only looking at a 25-degree delta T. But in cold climates, it could be 0 degrees outside, 70 degrees inside. Now you're looking at a 70-degree delta T. So this is a cold climate issue with conventional, even Energy Star windows. And as an example, I just ran some calculations for a cold climate with only 15% of the wall actually window area. And then I showed various R value assemblies for the wall assembly from R0 to R60 in the horizontal axis across the top, and various U values for window assemblies from an Energy Star 0.3 U value all the way down to 0.1, which is R10 window. And the reason I did this is it helps me highlight how important the window is in cold climates. So if I have, let's say, a 2x6 wall, R18, effectively with the windows, it drops it down to R11, even with about an Energy Star window. So I'm losing over a third of the effective wall insulation with a window. As I move to more and more efficient assemblies, like an R39 wall, right, which is like, that's going to be a 13-inch wall, I'm losing 60% to 2/3 of the R value with an Energy Star window. That 39 effective drops to R15. And I can get as good as an R39 wall with an Energy Star window with a 6-inch wall and an R7 window, triple glaze window. And note that the R60 is losing like 75% almost of its R value with an Energy Star window. And I can get to within R1 of the R17 with an R10 window and a 6-inch wall versus like a 20-inch wall. So the window is absolutely essential. And we now have a low-cost triple pane window. It's called a thin triple low-E window. It basically uses interior pane of glass that's like that used with float glass and LED televisions. And then, of course, you have the additional low-E coatings. You use krypton gas, which now has dropped in price significantly. But the reason why it's low cost is, first, it's lightweight, much lighter than a triple glazed window with 3 regular panes of glass. And secondly, the manufacturers don't have to retool to make it. It's the same width as a dual pane window. So they don't have to redo all their equipment to make a thicker, a window that can handle the thicker extrusion for the glass. So tremendous cost reductions. We'll see how it plays out as they come to market. There are 2 or 3 window manufacturers currently just starting to provide this product. It's a game changer in cold climates. And then bulk moisture is obvious. We have to keep moisture out. There's no tolerance for drying. You have to be bulletproof. It's not hard. You shouldn't be scared. The basic details work. Roofs, walls openings and penetrations, foundation and site. The basic details work. Again, time is tight, so I don't want to dwell on each of these. And there are great books. Joe Stiebert just came out with his 2nd edition of the Moisture Control Handbook. Everyone should get a copy of that book. but there's great resources for how to do water control. I will give you just the basic concept though. If you have any kind of assembly, and I challenge you, what would be the flashing solution for this? All of you should be able to draw something like this. It's basically doing a couple things. One is shingle fashion, taking moisture from one component to the next component, and then having little bends where one cap goes to the next. So you can break the cap, can have a capillary break to stop water from siphoning up. And then in shingle fashion, with certainty, the assembly will dry, or the water will shed, and you'll keep a dry assembly. And that's how we develop these details we show you for, let's say, a window opening. It's all using that shingle fashion strategy. You have the flashing above the window, goes above the flashing around the window, which goes over the flashing on the side of the windows, which goes over the flashing at the bottom of the window, which is a pan flashing because we know 100% of the windows leak. When we put the window in place, we make sure when we have sealant, we don't use sealant at the bottom edge of the window so that the pan flashing can drain to the drainage layer that's called the weather resistant barrier that's on the sheathing. It's just shingle fashion taking the moisture off the assembly. This isn't hard, it's just being committed to the diligence to do all the details. So you don't want to miss, for instance, the flashing at the drip edge where you have the roof sheathing exposed. You have to make sure you have that final cap flashing because water will wick right into the OSB or plywood way too easily. Similarly, where a roof meets a wall, you want to make sure the last piece of step flashing kicks out and directs the water away from the edge where it can cause damage. These are such basic, simple details. And then capillary breaks are critical because we have to make sure if we have water going behind virtually all claddings that it has a place to drain. And with the air gap, it could drain. So these aren't extra credit details, these are mandatory. There are some sidings that do allow for drainage, like surprisingly vinyl siding will allow for draining even without the furring gap between the weather resistant barrier and the vinyl siding. But most claddings will need to have a capillary break. So we have to know we do these things. And we know with certainty that no one's going to replace their drain tile once it's installed. No one's going to excavate, go down 6-7 feet, pull the drain tile and replace it when on the left, like in many applications, it will basically fill with sediment through the openings over 7 or 8 years. So when we construct the home, we do plan for the future. We wrap it in a fabric filter, or we have the gravel around the drain tile and wrap that whole gravel and drain tile in a fabric filter, any way we choose. But we've got to do comprehensive moisture control. Enough about that. Moisture vapor is a combination of lots of factors. Airflow stops the moisture from being carried in with it if you have good airflow control. Diffusion is the moisture that will just go through the material itself. Comfort systems also help with moisture control. If they're installed properly, they have less leakage, let's say in damp basements or damp crawl spaces or damp attics. Whole house dehumidification is a way to control moisture. And then with indoor air quality, we do whole house ventilation to dilute moisture in the home and to also help. A part of its purpose is dilute moisture in home, and spot ventilation in bathroom and kitchens also dilutes moisture. So we have all these strategies, but the key are airflow and diffusion. That's your main enclosure elements that have to deal with moisture vapor. And the key point I want to get across again is simple, is air leakage is overwhelmingly more important than diffusion. So on the left, you have hot, humid climates. On the right, you have cold climates. And in the bottom assembly, you have a 4x8 drywall sheet, unpainted, 1-inch hole. On the top, the 4x8 unpainted drywall without the 1-inch hole. And in a hot, humid climate, the difference is over a winter season, 3/4 of a quarts of water go through. And with a 1-inch hole, 7 quarts. So 10 times greater moisture flow through the air leakage hole than just through diffusion. And in a cold climate, it's 100 times greater, 30 quarts versus 1/3 of a quart. So it tells you if real estate's location, 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 moisture control is air leakage, air leakage, air leakage. If you do a great job with that, with your air leakage checklist we talked about earlier, you're just like 90% of the way towards doing a great job managing moisture vapor control. Now, we mentioned all the components inside the house are more than half the energy use. And if you want an all electric home, all I want to do in terms of all electric is let you know there are great choices to get you there now. I'm going to talk about a concept electric ready in a moment. So you can either put them in now or be ready for them in the future. So for comfort, we know we have cold weather air source heat pumps that work beautifully. They maintain both capacity and efficiency down to almost minus 20 degrees Fahrenheit. We have geothermal heat pumps, can operate in any climate zone. For water heating, we have heat pump water heaters that are now have ducted models and offer double the efficiency of an electric resistance water heater. We have very little use of solar water heaters, and I keep always wondering why this technology is left aside. I see lots of opportunities for solar water heating. For the appliances, lighting, fans, and fireplaces, there are lots of electric options with Energy Star labels. In the case of cooktops, gas cooking is often a preferred technology. Induction cooktops cook faster, safer, better once you learn to use it and use ferrous iron cookware. And a really new player is electric fireplaces that have come on the scene that are amazing. Then smart home these all need to be smart integrated. So connectivity, essential portal, and sensors, all those will have to be factored in. And more grid integration will have to be factored in as well with solar batteries, demand response, and various shutoffs that are needed to maintain power during supply shutdowns. One example of just, again, the electric fireplaces really intrigues me, just how good they've gotten in a very short period of time. And I don't know if a lot of people paying attention to just how, if they have a client or a market that really values fireplaces, this is an amazing option to consider. Now moving on to the comfort system, we have to be aware that we have an epidemic of poor quality installation. The culprits are oversized equipment, which lead to inefficient cycling. We have improper airflow because we don't spend enough time with duct design, air leakage, duct leakage, and that increases friction and static pressure. Improper refrigerant charge can lead to reduced capacity for the system, and excessive duct leakage means your conditioned space comfort will suffer. High bills, reduced comfort, durability, and the rates at which we're observing the quality issues with HVAC systems are astounding. Equipment is high, oversized, a third to 93% of the time in measured field studies by the National Renewable Energy Laboratory. Airflow testing is low, half to over 90% of the time. Refrigerant charge is low, almost 30 to 80% of the time. And duct leakage is a problem 2/3 to 100% of the time in all these randomly tested homes over and over across the country. This is an epidemic of quality installation. So we have to be better. Energy Star program has a great protocol for quality installation. Now the HERS ResNet program has quality installation integrated in the score that you achieve. But it's the basics. You got to design the system, the loads, and select equipment that meets the load requirements, and actually design the duct and enforce the installation to that design in the field. And in humid climates, you have to have solutions for that high latent capacity because you're now in a high performance enclosure. You can integrate it with the variable speed equipment or have a dedicated whole house humidifier. And what's critical is all the commissioning, checking airflow, checking charge, and measuring airflow at all the registers, even the exhaust fans and the ventilation ducts, all that should be measured to make sure we have comfort and throughout the house. One more point I'll reemphasize is the comfort system in the attic is insanity to me. You have 10 to 45% additional thermal losses. It's working against the most egregious conditions for the summertime, and winter is almost as cold as it is outdoors. This is not where ducts belong. On the right, we always know we crawl in an attic, it's full of dust and moisture. This is a horrible solution. There are lots of ways we can get ducts either in the conditioned space, between floors, drop raised ceilings, conditioned crawl spaces and attics. And then we can have ductless systems that do a great job and really attracting a lot of interest. And as an option that's there is to bury the ducts below the insulation. But I again keep trying to make the point: you don't want an unvented attic. You want a vented attic. You want an unvented attic. So hopefully, this last buried duct option shouldn't be part of high performance homes. I should mention that there's amazing game-changing technology, plug-and-play ducts. Name's RIA is the first manufacturer. It takes the installer out of the equation, both for design, installation, and for airtightness of the ducts. They snap in airtight, and they're dedicated runs from a kind of a mixing box at the top of the plenum, where you have dedicated lines to each room. They're all the same size, so the number of lines to each room is all pegged to the CFM flow requirements you need by the design. Also mentioned advanced comfort systems in cold climates are amazing. They're smaller, they're more efficient, they're incredibly impressive how they maintain capacity and efficiency down to -20. They're so small they can be mounted up above the snow line for better performance. Again, lots of new solutions for electric. And a lot of these new systems have really impressive other smart capabilities. They know if people are in the space, they know if the space is getting proper mixing or not, and they make all sorts of automatic adjustments that are just fantastic for high performance homes to maximize comfort risk that we talked about earlier. Okay, moving on to indoor air quality. I want to just tell you that very few people realize that we consume almost 8 times more air, ingest 8 times more air each day than food, and about 4 times more air each day than water. And that air is really important. And the exposure potential to mold, dust, mites, dust, formaldehydes, for VOCs, combustion gases, soil gases, we have tremendous value for comprehensive indoor air quality. And we also have metrics that show the risk is great. EPA documents 2 to 5 times greater contaminants indoors and outdoors while we spend most of our time in the homes. 1 in 10 children suffer from asthma. At least 80% of home buyers and homeowners of all ages are willing to pay more for a healthier home. And this was a study done in 2015. Move up to COVID and post-COVID, and this has to be like well over 90% the interest in good health at home. And the strategies are simple and basic. Again, I always like to make it simple. It's not hard. Keep the bad stuff out with source control. The control layers are really important that we did in building science as a first step. There's a freebie. They help manage source control, dust, pollen, molds from getting inside the home, screens to keep out pests, low and no chemical materials in the home, and whole house dehumidification for moisture that can lead to mold. And it's basic. Fresh air, whole house ventilation, and then spot ventilation for kitchens and bathrooms, and then high capture filtration, whole house air filters, central vacuum cleaners are good for taking a lot of dust from vacuuming outboard the house, or there are a lot of much improved HEPA filter vacuums that also are a big improvement from the old vacuums that were not as good. And so these are the contaminants, these are the strategies. Due to time constraints, I'm going to beg off this slide just to make sure I get through all my slides, but know that we have solutions for all the contaminants. For instance, with a lot of board products, cabinets, adhesives, and carpets, there are label products that get us low VOC and low formaldehyde or no VOC formaldehyde content. And all you have to do is specify the right label. For radon, we know the locations where it's a risk. 1 in 15 homes have excessive levels of radon. Most significantly, 21,000 lung cancer deaths each year attributed to radon, and that's with 3,000 people who have never smoked. So this is a huge health issue in the country. And the systems are so simple. We get a freebie with moisture control. We already have a poly layer under the slab. We already have the gravel that collects the air as well as the moisture. And we also already have sealing and caulking around any openings like sump pumps or any penetrations into the slab. So all we need to do for a radon resistant construction is put a vent pipe so the soil gases can vent outdoors, and put a junction box in a location where a fan can be added later if the passive ventilation is found not to be adequate to get to the 4 picocurie threshold currently by EPA for radon. So these are real easy and basic to get to radon. Whole house ventilation, the choices are exhaust only, where you just pull air out and let the negative pressure in the home pull air through whatever cracks are left. Supply is reverse, where you have an inlet to the return from outside that pulls air into the conditioned air being run through the air handler, and then it pressurizes the home, and the rest of the ventilation happens by pushing air out through remaining cracks. And then balance only brings in air and exhausts air both. And everyone wants to eventually get to balance, if not mandatory right now. To rely on cracks and holes left in higher and higher performing homes is not going to work. All the studies and research I've read show much reduced ventilation with exhaust and supply only systems. So everyone should be moving to balanced. They're dedicated heat recovery ventilators and energy recovery or enthalpy recovery ventilators. I think more and more everyone's going to ERVs, which provide both heat exchange for greater efficiency and moisture exchange for better comfort and health. So I think more and more you'll see it's almost a minor or no cost difference to move to an ERV when you choose a dedicated system. Also, there are simple integrated systems where you combine supply, again, that inlet to the return duct with a damper and your exhaust fans, and have a controller so they work in sync to provide balanced ventilation at the lowest cost. You'll miss the efficiency gain with the heat exchanger and the moisture exchange, but it's a much lower cost way of doing balanced ventilation. And there's some really interesting technology. This through the wall system is really great for small apartments because it's through the wall. I don't need ducts. It's like really low wattage, 90% heat exchange, about 20–30% moisture exchange, only like 8 or 9 watts. It's almost like a night light, and it's incredibly quiet. It pulls air in, out, then stops, then pulls outdoor air in across the ceramic module. And it's a really good option to consider for small units, particularly multifamily housing, where it's really hard to figure out the ductwork and how to do balanced ventilation. And lastly, high capture filtration. The average amount of dust collected in a 6-room home is about 40 pounds a year, which is a scary thought. Even worse is a study that shows that dust can be laced with 45 different toxic chemicals. So filtration is an obvious winner, and again, something I believe most American households will pay for. So everyone should be thinking about the thicker, high capture filters in the systems, and therefore you have to plan for a 4-inch filter rack when you do a comfort system. Resilience is really, the science tells us this is the future. 90% of the warming on Earth the past 50 years has occurred in the ocean. Doubling of warming with water vapor than just CO2 in the atmosphere alone. So we're like exponentially increasing global climate increases because of water vapor now that's being driven from the much warmer oceans. And as a result, 21% more storms for every 1 degree centigrade increase in sea surface temperature. We've had so far about 1.5 degrees, and we're moving towards much greater increases. About a third of carbon's absorbed by the oceans before it gets to the air. And as a result, we're forecasting a 60% increase in extreme storms by 2100. So if you think we're going crazy now, it's just almost baked in, just based on scientific principles, the growing intensity and frequency of climate-related disasters. And if you look at a map where climate disasters occur in the country, this is where they occur. If I overlay where we live, these are 11 megapolitan regions where 70% of the US population lives, and like 80–90% of it's right on target with where disaster risk is the highest. And the estimated value is $6.6 trillion of exposure. So it's insane how much risk we have. And look what we paid the past decade, almost $1/3 of $1 trillion for property losses due to disaster risk. The industry is responding with discounts. So if you live 3 feet above base flood elevation, you save over 10 years, you'll save about $10,000 on your flood insurance, you'll save $90,000 if it's 3-4 feet below flood elevation, base flood elevation. And of course, beyond just high cost, it's also just the availability, as insurers just can't find a way to take on the risk of greater disasters. So they're pulling out of certain markets, and prices are going up even more exorbitantly. And it's also as a result affecting real estate value. And study after study is showing evidence that already we're seeing winners and losers. One study just in the tri-state region, New York, New Jersey, Connecticut, since 2005 has calculated a $7 billion drop in value, in property value. So these are all happening. We know what to do to manage disaster risk for the event itself and how to maintain occupancy post-disaster. Time's short, so I'll just let you know, if you know, a lot of my writing and my new books really go into these in a lot more detail. But the key point I want to let you know is some of the choices you make to do zero carbon to achieve high performance enclosures can complement or conflict with your goals for disaster protection. So for instance, for wildfires, you want to do unvented attics so embers can't get in, unvented crawl spaces so embers can't get in, more fire-resistant construction like concrete, insulated concrete panels. High wind impacts improve with unvented attics and with walls made of concrete, SIPs, insulated concrete panels, spray foam insulation and cavity. All these things can be done to optimize your disaster resistance for high wind and impact, hurricanes and tornadoes. And earthquakes benefit from wood framing, SIPs are helpful, and spray foam will strengthen your assembly as well. And then water, we mentioned, is becoming a big issue, way too big a topic to cover today. But just to say, it's really easy to do. Just energy efficient water fixtures and more efficient solutions for getting hot water from the heater to the fixtures. There are like 3-4 strategies for how you can do that. And then outside irrigation is a huge waste of water if it's not efficient. So there's efficient irrigation controls to do that. And then the last piece I want to talk about on this performance side is optimizing electric ready. And so here, essentially, there are a whole bunch of electric ready components for appliances, cooktops, and clothes dryers. Heat pump clothes dryer is a great new electric enhanced performance solution. Water heaters, heat pump water heater, furnaces. So if you choose not to do those and you're using gas cooktops and gas clothes dryers, just make sure you bring the electric amperage lines to that location so you can switch in the future. Same for water heaters and furnaces. Make them ready to switch if they're not electric technologies now. For solar ready, it's just a matter of conduit from the roof to the circuit breaker, knowing giving the homeowner the load calculation so they can know that the solar can be added without having to go to a structural engineer for a whole new $1,000 or $2,000 expense, and leaving space for balance of system next to the circuit breaker box. EV ready is a matter of pre-installing conduit, 40 amp to 40 volt, and having a level 2 ready outlet. So you know everyone within 5 to 7 years is going to be looking for electric vehicles. Don't be obsolete and impose significant extra costs that you could do much lower cost. Make it EV ready. And battery ready is about having a 225 amp bus bar and separately setting up the circuits for backup power. You don't run backup battery power to every outlet and every piece of equipment in your home, prioritizing setting up those circuits, and then having a sub panel or split bus main panel for being able to toggle. So when there is a supply interruption or a post-disaster event, the backup power with the battery and the solar, everything knows where to go. So all these things are ready to make homes electric ready. And it leaves me with the 2 last sections, which I think I can do pretty quickly. And this one's really important, that a lot of us may judge people at various steps of high performance, and we shouldn't. Zero carbon is a journey, and everyone will have their path, but I think everyone should be on the path and know they are. And the path is from code minimum to high performance to zero ready, to zero net energy, to zero energy that's all electric, to zero carbon. And that will all address your operational energy. And anywhere along that way, you want to start reducing carbon, concrete, steel, some of the foam products in your homes to reduce the embodied carbon. That is a great option for you as well. But it's a path for how we get there. And I'm going to lay it out for you by showing a comparison of performance, water control, comfort systems, and air quality, all those things that we do for performance. What's the resulting energy consumption with and without fossil fuel? And that will be blue bars versus the gray for performance. And renewable energy is a green bar, and embodied energy is the orange bar. So if you look at a code minimum home, the metric numbers are not important. You have a certain amount of performance in gray. You have a certain amount of energy use that's with and without fossil fuel. No renewable required by most codes, all codes except maybe California. And then you have the embodied carbon in the materials. And that's what you have in a code home. And when you go to high performance, you ramp up the gray bar so it's higher performance. You reduce the energy use, maybe 15, 20, 30%, usually 15 to 20%. You still don't have renewables and you have the same embodied carbon. But the energy use compared to embodied is getting closer. When I go to zero energy ready, I even further increase performance, more rigor on air quality, more rigor on comfort and moisture control. And then I even have reduced energy use and I have no renewable requirements, so that's the same. But notice the carbon, embodied carbon now is the same as, or close to the same to the energy use. It's gaining in importance. If we don't address embodied carbon, that's half of the carbon that we're trying to mitigate. And we go to zero net energy, now we have renewable energy either on-site or off-site. When we go all electric, now that energy consumption is all electric. So now we have no carbon on-site with the operational energy because we're offsetting it with renewables. So here we may have some carbon that's not being offset. Now we've done it. And in zero carbon, we actually have even more renewables to start addressing the embodied carbon to get to zero carbon. And anywhere you can get to start getting on this path is what we should be encouraging people. Not saying if you're not doing one of these levels, you're not doing enough. All of us have a journey, and we just have to encourage and embrace everyone to get on the path to zero. And we have all these options for how to do this. These are the national programs. High Performance Energy Star is a great start. Air Plus brings in the air quality, Water Sense the water, Fortified Home brings in the resilience, and then the green programs are there. If anyone wants to ask me after the session's over why I struggle with green programs, I'll welcome the question, but we have that discussion later. For Zero Ready, we have Zero Energy Ready Home from DOE, Passive House, and Passive House Institute. The next version of Zero Ready will have a zero net energy option, in other words, zero energy with including renewables, as does Passive House and Zero Energy certification from Living Building Challenge. Zero Energy All Electric, we're toying DOE and EPA with an all electric label, so look out for that. And although not a national program, SMUD in Sacramento has an all electric smart home program to start providing incentives for all electric homes. And Zero Carbon, call attention to the Living Building Challenge, Zero Carbon certification. And the Carbon Trust is already labeling products relative to their carbon content to help get to zero carbon. So you have all these tools and resources for how to get on the journey. Just let's do that. And let me wrap up in about 5, 10 minutes, 8 minutes with why zero carbon is not enough. I love this quote from Steve Jobs: if you keep your eye on the profit, you're going to skimp on the product, but you focus on making really great products, then the profits will follow. And I will suggest it's all user experience that drives great products. And the reason why I believe housing is the ultimate consumer product, and this is a huge awareness point for me, is Lawrence Berkeley National Lab surveyed thousands of homeowners and came up with this amazing statistic. This is where we spend our time each day based on the survey. And what you need to take away is we're in our homes nearly 70% of our lives. Every day, 70% of our time is indoors. So my whole program I do working with the industry on user experience is called Housing 2.0. And what it's about is that home is where life happens. We have to address housing as a system. Performance is just not enough. And more importantly, the buyers are getting more and more informed about user experience. First of all, almost everyone goes on a website before they buy a home. And now more and more builders are getting exposed to peer reviews about the user experience. And I would suggest this is one website of about 6 or 7 that has these peer review results for various builders. 2 things to notice. One is some of these reviews are over 1,000 number of reviews. Second, there are 1-star builders and 4.5-star builders. I won't even go to a 3-star restaurant or lower for an $80 meal. What's the chance I'm going to buy a $500,000 home from a 3-star builder or less? The imperative to deliver user experience is coming, if it's not here already, almost in a blip of time. This is where you have to be. You have an imperative to optimize user experience. All to say, zero carbon, health, it's not enough. Everyone expects community, daylight, fresh air, outdoor spaces, storage, smart homes, work at home capabilities, advanced lighting, color. I can go on and on. If the high performance builders are not housing as a system builders, they won't be the industry leaders. And so I've developed a basic spider diagram benchmark tool. I'm a tough scorer. I had the privilege to be approached to go and see tens of thousands of homes while leading Energy Star and Zero Energy Ready Home. And I give tough scores to the industry in terms of what the experience is on average compared to the opportunity that's there for the industry today. And if all I do is get a zero carbon home to deliver better performance, it won't get the job done. This is where people spend their lives. They're going to expect much more. Housing 2.0 optimization is where you have to be. So essentially, I have 5 user experiences that we showed you, 19 strategies, and 150 best practices. It kind of goes for community experience, there are 3 strategies, 21 best practices. For design, there are 5 strategies, 50 best practices. Performance, 5 strategies, 42 best practices. Quality, 3 strategies, 19 best practices. Sales, 3 strategies, 21 best practices. And if all I do is what most high performance builders do, which is building science, energy efficient enclosures, energy efficient components, indoor air quality, and this is all I have for the total housing as a system user experience. And so I'm committed to getting the industry there. How you do this is you have to realize that we know there are transformative experiences. Then you make investments. We know outdoor space is transformative. Color is transformative. Lighting, I can go on and on. Health and convenience and smart. All these things are going to transform the user experience in a place where we spend 70% of our lives. It makes sense that you invest in the experts and special features that deliver those transformative experiences. And you'll see the increase may be 10% per home. It's not that great because the same expertise and the same optimization lens will help you extract substantial cost savings for materials, labor, marketing, and sales at a net cost savings while delivering all this added user experience value and cost savings for owners over time. More value for less cost is a good business model. For example, this is what the performance industry doesn't sell in terms of all the added value that we've calculated before I left DOE, and I've done since I left DOE to further refine. But just the utility cost savings over a 30-year mortgage, for instance, are $20,000 to $60,000. And again, time is short. I'll just tell you health cost savings are about $30,000 to $40,000. If you just project about a 20–25% savings from the average $600 a year we spend out of pocket for health expenses. And so if we do the math and calculate these savings, there are huge opportunities just on the performance side. But think about just design as well, for instance. We normally build a house with an attic and a basement. And with a user experience optimization lens, I ask some serious questions. Why is this the way we build? I can take the wasted volume that's the truss attic and create an upper level up there with daylight and not a hard floor surface and not cold surfaces and just a completely transformative, better experience than a basement. And get rid of the basement with a shallow frost protected footing. So I trade off the low value basement volume for the upper level, which has maybe twice the user value and user experience. And the result is I can save up to $2,000, $6,000 for the shallow frost protected footing. All the extra framing in the basement for the finished basement, I don't need on the gabled ends and some other places could add up to $1,000 or $2,000. I don't need egress windows. I don't need all the air sealing and air barriers between the ceiling below the attic anymore that we talked about earlier. I don't need attic vents. The same crane that puts my SIP panels on the roof can put all the roofing in the roof. I don't need a crane or crews to walk up the roofing materials. I have about 2-3 dumpsters less waste, and I can build this in 3 to 5, 6 days faster at least. And so I get all those cost savings. And if I save $40, $50, if I add $40 or $50 of value per square foot for a much enhanced daylight space above ground versus below ground space, that's another $40,000, $60,000 of added value. This is what the user experience optimization capability is, more for less, and we have to get there. Good examples, my good friends Walsh Construction in Portland, Oregon, built one building on a site, then went to build a second building, applied the design optimization strategies, and reduced just cost to get added value by 24%. They could add passive solar for another 8% and still be 16% lower cost than the first building they built to code. Huge benefits. And so I'm going to wrap up and say, since I'm at the end of my time, I hope what you take away from this discussion is that keep zero carbon simple and recognize that once you get there, I want you high performance builders to be the user experience leaders. User experience leaders have 3 times greater return to investors than user experience laggards when 11 years of stock data looked at across the whole Wall Street stock performance index. And a McKinsey study found that the user experience leaders with the same metrics had 3 times greater resilience during downturns. So I want high performance builders to be user experience leaders so that the high performance homes are the most successful in the marketplace. New book just posted today. The pre-order has over 420 pages, over hundreds of graphics, 360 citations, and 7 of my favorite, best thought leader experts in the country provide some amazing essays to contribute to each chapter. So I hope you might consider this as a first step towards this user experience optimization approach. And I want to thank you all. This is a great privilege to do the first webinar in the Buildxact program. Thank you all very much.
Thank you very much, Sam. I must say, it's rare when you get somebody who is able to demonstrate really important concepts, but also provide you substantive solutions at the same time. So it's a credit to you. There's a tremendous amount of value in the time we've spent together. And as I say, substantive. And when Buildxact looks at this space and looks at the contribution of individuals like you, our primary question is, how do we take that information and make it actionable? And our platform has been designed to do exactly that. So Alex is going to jump on just for a few moments and show you 2 elements within the platform: how to build a template and how to build a recipe, so that you can readily see how some of Sam's concepts and principles and means and methods can be delivered into a programmatic way of working. And there's really 5 components to that. One is the provision of code, for example, 2029 IECC. And then the checklists, compliance checklists against that code. And then thirdly, your performance standards. And fourthly, the means and methods that you propose to adopt. And fifthly, access to the materials to be able to deliver against the principles that Sam just espoused to us. All of those things can exist in a templated form to allow a builder who is primarily a conventional builder looking to adapt green technologies. So over to you, Alex. We are running very, very short of time, mate. So we'll get you to stay really net on templates and recipes, and we'll allow a few minutes for questions at the end.
Perfect. Well, you know, I wanted just to thank Sam. I thought that was great. It's awesome to see some of the solutions that he provided. I think one of the main things that is my role, my name is Alex Volney, I'm an account executive here in North America, is I talk to about 20 to 30 builders a day. And one of the main issues that's become more and more common is regulations and different building codes around environmental building. So what has that led to is people are looking for ways to organize their business, because if you're not using any sort of software, you're just doing a lot of this stuff by hand, it's already overwhelming enough to do an estimate on your own without a lot of these different regulations and things that you want to make sure that you check for. So what I'm going to show you is how we can help organize your flow for your estimating, so that it's going to make it easier for you to make sure that you are as optimized as possible when it comes to zero carbon building. So the first thing that I'm just going to show you is just how to start an estimate. So if we go to the estimates tab here, I've already created what's called a net zero construction single family home template. So we can actually load a lot of these templates into the system for you, so that you can have a guidelines of what you're going to need to complete an estimate and to get that reduced carbon efficiency. So one of the things that is great about our program as well is that you're able to actually import your PDFs and blueprints to do takeoffs and measure them in the platform. This is going to help you even reduce your carbon footprint for removing paper from having to print out and do manual takeoffs. So to show you how to do that, if I go and use, let's say, drywall here as an example, and I open this tab in the estimate, this is how we work with the template. Is we're able to, from step 1 as a category to step 28, provide you with a list, essentially like a checklist of everything you're going to need to complete your estimate. And then on top of that, we're able to preload those in advance with different materials. So these materials here, we have organized into what's called an assembly. So right here, I have a moisture resistant drywall assembly that I'm using for my ceilings. So if I open this up, I'm able to actually have all of my different parts that are required, as in my drywall, my screws, my tape, and my mud, specifically outlined here with all of my materials directly from my supplier for the carbon footprint reducing materials. So the first thing that I'm going to do here is this is all of my cost per square foot and my breakdown of all my different materials. I just need to go in and measure the blueprints. So to do that, I can just press this takeoff tool button. It's going to bring me directly into my PDF of my blueprints. And for me to be able to figure out the exact materials I'm going to need, all I have to do is select one of these different tools up here at the top. So if I use this rectangle tool, I can highlight from one corner to the next, and it will tell me that it is 791 square feet and 9 inches to measure that ceiling for drywall. So now if I use this polygon tool here, it's going to allow me to measure my specific area. And once I've done that, just in a couple of clicks, it's going to give me a total of 2,136 square feet. If I press accept here, what that's going to allow me to do is our assembly is automatically going to tell you the exact amount of materials that you're going to need. So we've been able to take this 4x8 sheet of drywall, reduce that to a square foot cost automatically for you here, so that it'll tell you that you're going to need 66 sheets of this drywall that is moisture resistant for your build. So that comes out to a total of 2,948. So if we need to add additional things like calculate overage, or if you wanted to give yourself a bit of a wastage amount, what you can do is you can press this calculator button, which is going to allow you to add like a 10% wastage or round up, or even times this by 2 to double side the drywall. So it's really make sure that you get the right amount of numbers for your formula so you can be efficient and more accurate with your orders as well. So from here, if I wanted to go in and show you just some other things that we can do in regards to reducing your carbon footprint, is Sam brought up a really good thing regarding windows. So right here, if I go to my doors and windows, one of the very important things about our platform is we're actually able to import lists of pricing from your suppliers. So if you have a green building supplier, we can actually import that directly into the system, so that if I was wanted to look for a particular material from that supplier to build up my estimate, I can actually just browse their price list. I can go to doors, for instance, and then I can find one of the proper doors that to meet my requirements to be net zero for carbon emissions. So as you can see here,
Alex, thanks, man. I think in the interest of time, let's just go back to your estimate template window and just explain to the audience what that means. Basically, and I would lead you a little bit in that. So, for example, in the West, we would have Title 24. compliance regulations. Title 24 and all of the compliance requirements can be inserted into a template that essentially becomes a checklist for a builder to make sure that their means and methods are going to meet that code. And so we can go ahead and work with experts like Sam in the industry and with our builder customers to actually make sure that these templates and checklists exist in a pre-formatted condition in your project, so that you don't have to do it de novo every time you start a new job. I think that's enough, I think, on how we can apply. We certainly invite any of our guests today to contact Alex and to dig into the ability for us to build those templates and recipes a little further. Sam, I'm aware of one question in the chat box, and it really was the source around the rating system for the contractors. Can you just jump on and let us know what that is, and then I'll open up to any other questions to our attendees.
There are about 6 or 7 organizations that go about the process of surveying homeowners, usually I think within a month after they move in. So it's not capturing a lot of the user experience that extends and people find out about usually 6 to 12 months into ownership, but they just basically do a normal survey approach to getting the home buyers, which are public information. Every real estate transaction is public, so they email them for a survey response. It's a star rating system, and then they just aggregate the number of reviews to produce the score.
Okay, great. So any other questions from our audience? Hearing none.
I have one question for you, Steve, is on the takeoffs, if there's already a CAD set of drawings, can that inform the takeoff numbers? And also, I understood how they got the ceiling drywall calculation just by capturing with the shape of the ceiling. Where does the system know the height of the wall, whether it's 10 foot?
I can take that, Steve. Yeah, so Sam, basically whenever you're doing a line measurement, whether it be linear foot or square foot, you can always put in like the height of the ceiling if you'd like. So you can actually use a line tool and manually put in the height of the ceiling as 10 feet. Or if you have a front elevation blueprint, you could just use that same tool that you saw for the ceiling. So basically every single way that you can measure, we take care of in terms of takeoffs. And I do have a question for you, Sam, as well, which I think would be helpful for some of the people on this call, is a lot of people don't know how to get started in terms of like where to go to get the right information in terms of, they want to build green, but they don't know how to start that estimating process of being accurate. Do you know like what's the, just a piece of advice of like, where's some resources or ways to start thinking green to get people rolling and more organized?
God, such a great question. I'll tell you the biggest problem, Alex, in getting started is there's the price it costs you to start, and then there's the price you get to with the learning curve. And the learning curve price, once you figure out the systems, can be 30, 40, 50% or lower than that first time you did it. You know, when I first get a piece of IKEA furniture, like a dresser, and I assemble it, it might take me 4 hours. I love the dresser so much, I get a second one for my daughter, and then I assemble the next one in 1 hour. And what happens again is a lot of times we try a new technology, new software, or a new system. We run into one bug or something that gives us a blip in our ability to process it, and we lose confidence or we get frustrated. And you have to get past those. And the biggest challenge, I think, for people moving up to high performance will be there's lots of places where that can happen. And so you really need really great support system. It could be peer built, you have good relationships with high performance builders. It could be your HERS rater, him or herself, could be someone to hold your hand through a lot of the learning curve parts. A lot of manufacturers are able to do that with you directly, but you got to give yourself a chance to at least experience the difference post learning curve, and then you'll know. The other big problem is that the cost accounting is, if I just compare a framing package to a SIP package, for instance, I'll go, the SIPs are too expensive and walk away. But once you understand all the value of time, the value of less rework, the value of less dumpster requirements, the value of having true dimensions for installing finishes and cabinets, when you count for all the benefits of the built-in insulation and quality control systems, it's like, systems are not set up to do all the cost accounting. So, so you need to work with people when you try something new, have experience and benefit from them. And I think that's the biggest problem I see with moving to higher performing and zero carbon levels of performance. You have to understand what the costs are once you learn the systems.
And well, that is very true, Sam. But I would want to emphasize to everybody listening is that's where technology can help. This is where the power of these templates and the recipes that are authored by people like Sam that can exist inside of Buildxact to make sure that you don't stub your toe the first time out of the barn, right? And that will begin saving that time, and it'll give confidence and eliminate risk from somebody who's willing to move to high performance building. So it's very exciting to see these ideas come together today, because I think we can really help our audience because I know that they're quite passionate, and as Alex asked, trying to find their way into this space. Sam? All right, I've got a couple of minutes left. We can take another question, or are we all good? Jennifer, can you hear me? Are we okay?
All good. Thank you everyone for attending, and thank you, Sam, for presenting, and Alex and Steve.
Yeah, thank you, everybody.
And feel free to reach out if you're interested. Just give me a call or shoot me an email, and I'm happy to go over how we can get you on board with a special rate for Buildxact.
Okay, thank you, everyone.
Bye.
Have a nice day.